In this Part 2 tutorial animation, we continue creating our pick-and-place program using the RoboLogix simulation software package from Logic Design. To review, the objective of our program was to pick up a box from the end of Conveyor 1 and place it onto Conveyor 2. In our Part 1 tutorial, we identified the 12 sequential program actions required to accomplish our desired task. We also identified the 4 significant tool center point positions required to perform the task. At this point, you may wish to pause the animation to review our collected information. We also created a new program file and began to enter the sequential commands required to execute the desired task. In this Part 2 tutorial, we'll continue on to complete entering and examining the sequential commands required to complete our pick-and-place application. We'll begin by locating and selecting the program we began in Tutorial 1. We then click on the Load button to bring up the partially completed program. At this point, the program positions the robot arm in the home position, starts Conveyor 1, and waits a long enough time duration for a box to reach the end of the conveyor. We're now ready to add an instruction that'll move the tool center point to a position directly above the box. RoboLogix provides 2 types of motion instructions. The first instruction is the linear motion instruction. This instruction moves the tool center point in a straight line to a specified position register location. The second is the angular motion instruction. This instruction moves the tool center point in an angular motion to the specified position register location. Both motion instructions are designed to work with the position register. The position register is capable of storing up to 10 distinct tool center point positions. These positions are indexed 0 through 9. The position register index number is used to populate the motion instructions. As an example, if we use position index 5 with the linear motion instruction, the tool center point would move from its current location in a straight line to the location specified in the P5 position register index location. We click on the New button to continue adding instructions to our existing program. We select the angular motion instruction to move the robot arm in an angular fashion over Conveyor 1. The angular motion command setup dialog box now appears, allowing the user to define the position register index value for this motion instruction. In addition, the angular velocity can also be defined. We'll be storing the actual position data to the position register in Tutorial 3. For now, it's enough to reference the index location where this data will be placed. As this is the first location, we enter a value of 0 and click OK. Once again, we click on the New button to add our next instruction. This time we're going to move the robot arm straight down to the conveyor. For that reason, we select the linear motion instruction. The linear motion command setup dialog box allows the user to specify the position register index location. In addition, the user can define the velocity at which the motion occurs. As this is a separate location from the first one we moved to, we set the index value to 1. We then click on the OK button to add the instruction to our program. At this point in our program, we've moved the TCP to the location where it's possible to grab the box. We click on the New button to add the Close Gripper instruction. We select the gripper instruction from the Program Line Entry dialog box and bring up the gripper command setup. This dialog box allows the user to either open or close the gripper. As we desire to pick up the box, we set the value to close and click OK to add the instruction. In this way, we'll continue on adding the instructions to move the tool center point to the desired location or pick up or drop the box as needed. The next instruction to be added to the program is a linear motion instruction. We reference the index 0 location as that's the location directly above Conveyor 1. This instruction will lift the box above the conveyor. We then add another angular motion instruction. This instruction will pivot the arm over top of conveyor 2. We use a new reference index number for the position register, as this is a unique and separate position and requires a unique reference index number. With the robot arm now positioned directly over conveyor 2, we use a linear motion instruction to bring the arm down to a position from which we can drop the box onto the conveyor. Once again, we have a new unique position that requires a separate and individual position register index number. With the TCP now located just inches over the second conveyor, it's time to open the gripper and drop the box onto conveyor 2. Next, we raise the robot arm to the position directly above conveyor 2. This is accomplished by adding another linear motion instruction and referencing the index number we selected when we initially defined that position. With the robot arm and TCP clear of conveyor 2, we add the home instruction to return the arm to its original point of origin. Lastly, we add the end instruction signifying that the program should be terminated at this point. In the third part of our tutorial, we'll do a walkthrough of the application using the jog buttons. We will save the 4 required positions to the position registers and run the program to test and debug it.